Hi, my name is Xing Liu, a PhD student from Computer Vision Lab of Delft University of Technology. I'm going to present our paper, No Frame Left Behind, Full Video Action Recognition. As we may know, training deep networks on all video frames when actions develop over hundreds of frames is computationally infeasible. What people commonly do is uniformly sampling a small number of video frames and using these to recognize the action. But not all video frames are equally informative for recognizing an action. In this subsampling 1 example, one cannot tell if it is making scrambled eggs or making pancakes. While in this subsampling 2 example, one can tell for sure it is making scrambled eggs. So we want to make training with full video frames computationally tractable by clustering of frame activations along the temporal dimension and aggregate the frame activations in the clusters into a small number of representations as shown in this figure, which saves computation memory. The key idea behind the aggregated temporal clusters is that we want to calculate a single gradient to approximate the gradients of a group of frames that are alike. In this formula, the xi means the activation and the w means the weight. The left-hand side shows the conventional calculation of gradients, while we want to approximate it with the right-hand side calculation, which is first getting the sum of activations of a group of frames and calculate a single gradient to reduce the computation memory. But the right-hand side only holds under the condition that both activation function and the loss function are linear. But we can make the activation function relu linear by grouping the frames that the sign of their activation values agrees. And we also show the error bound to explain the nonlinearity of the loss function. This graph shows how we do this temporal clustering and aggregating to get the aggregated frames. We first calculate the Hamming distance for neighboring frames and get the cumulative distance for them. We tried both cumulative clustering and slope clustering in our paper. For cumulative clustering, we first divide the cumulative distance in 3 equal parts, which means the 3 number of clusters we want. And then, as shown with the dashed blue line, the frames are grouped into 3 clusters. Well, for the slope clustering, we first find the 2 locations where the distance changes most, and then group the frames into 3 clusters as shown by the green vertical line. In this way, we group all frames into a fixed number of clusters G and output G frames to match the available training memory. Our method groups and aggregates the input frames activation for every video in the batch size of M at an early layer as shown in this figure, and outputs G aggregated frames for each video in the batch, which utilizes all frames and saves computation memory. We evaluate our methods on several video action recognition datasets. For breakfast dataset, our method shows an advantage on long-term video action recognition by using all frames, while for shorter videos, like something, our method achieves limited accuracy over subsampling strategies. In conclusion, we propose an efficient method for training action recognition deep networks without relying on sampling heuristics. We efficiently find frames that are similar with respect to the classification task. Our proposed method shows competitive results on large datasets when compared to existing work. Thank you.